basically start talk about what is actually GluonNLP. So you guys must know Gluon, right? Which is like Python front end of the MXNet. And GluonNLP is based on Gluon, so it's designed specifically for NLP, natural language processing. So the GluonNLP is actually a deep learning framework designed for fast data processing, data loading, model building in the NLP area. So I think for today, I will basically let you guys know the key components in the GluonNLP, rather than just go over lots of stuff and just finally just get nothing. So I basically will focus on these three high-level APIs. I think is very important and essential for either NLP beginners, just know a little bit of NLP, or even for advanced NLP users. You want to leverage a technique for your own production or for your own business. That should be fun. So these three APIs I think is essential, and it should be able to help you to do anything you want for any NLP relevant tasks. So I will basically cover the first one is GluonNLP data API. It's a very high-level API. It's designed for efficient data pre-processing and loading, as well as a GluonNLP model. I think it's just designed for you to fast prototyping your model. Anything you have in your mind, you want to quickly try it. So we designed this model API for you to define your model, train your model, load some model, pre-trained state-of-the-art language model, for example, machine translation model already actually existing in the model zone in GluonNLP. So we actually have lots of pre-trained model for many common NLP tasks as well. So in this API. So finally, I basically want to cover a little bit about the embedding. So because actually embedding is very general, usable, so it can be applied to many of the tasks, like high-level tasks or low-level tasks, like NLP tasks, or even for some recommendation tasks. I will basically cover that, how to leverage the embedding. Already, we also have the embedding, pre-training embedding, over 300 pre-training embedding, as well as you can define your own embedding model as well to just train it and have your own embedding ready for many NLP tasks, or even some more applicational tasks. Okay. So before I delve into what is how to actually leverage the three APIs to build your first, for example, language model later on we will talk about, I will say thanks for this guys who makes it happen. Sean, me, Aston, Mu, and Shuai, Leo, and Xingjian. They are not necessarily in Amazon, but have some relationship with Amazon, but we make it happen. And our code is actually available here on the MSC, and we have the very detailed API document as well available here. So this project is relatively new. So actually it starts around 3 months ago, 3 months ago. And actually we now already got like 877 followers in GitHub. And I think we also have this kind of forums for you if you find issues using this toolkit and you want to find out how you want to propose some new features in the repository. You'll come to just discuss or contribute in GitHub. So let me first introduce some interesting stuff we currently are able to handle in GluonNLP. So most of them I would say is state of art in NLP area. So I will basically cover what is the advanced features and what is the ultimate performance actually now in GluonNLP. So the first thing is regarding to the data API. So we will talk about the technique called data parking. I think the data parking is actually a very useful technique if you want to really train your model. You want to basically think about how you want to generate the mini batches very efficiently, because for the normal machine learning model, you basically use a mini batch to update the parameters. So that's basically a base for how you can efficiently train a model. So we actually develop this parking technique. So let's first talk about if there's no parking. So for example, we get this kind of can you see my pointer? If you see this kind of parking examples, for example, so different samples have like different lengths in NLP. So for example, you have some longer samples, you have some shorter samples, but you want to leverage the model to train your model. But you can see from the picture actually the samples have different lengths, right? And if there's no parking, so basically what will happen is that you will basically need to append every samples to the same length. So how you can do that? Normally you will basically first find the maximum length in all your data samples and use that one to kind of pad, to just pad every samples to that sentence, to that length. And then, for example, for this data samples, what you will have is actually the average padding will equals to 11. So that means So that means basically, average for each sample you have 11, kind of empty stuffs that just occupy the memory and doing nothing. Just make your algorithm run. So in this case, average padding equals to 11 will make your data loading very slow and it's very memory inefficient. And what we can do is actually, there are many strategies in the GluonNLP, but I will basically cover a very basic one. So the idea is very simple. It's basically you have some bucket. Okay, each bucket will have some bucket size, and the bucket size will you basically have this. First for them, first 10 samples in the first bucket. And what you will do is just sort the bucket based on the sample length, right? So actually, then later on you will find the samples is just ordered from the longest one to the shortest one, and then you can basically do the batchify based on the ordered samples. So for each of the samples in the bucket, so basically you will have smaller padding tokens compared to no bucketing strategy. So average padding will equal to 3. So you will save around 8 tokens per example. So that's a large saving, and you will get your data loading faster as well as memory efficient. Yeah.
Does that introduce any possibility of bias where there's a correlation between the types of documents that are very long, the types of documents that are now short, and now they're going to show up all the long documents are on the same mini batch? Maybe they all have the same kinds of tokens, whereas the very short documents are also correlated?
Yeah, that's a good question. So based on our experiments, at least for language model and neural machine translation, there's actually no such bias. So you can say actually the worst distribution over the longer seconds and the short seconds are very similar. So there's no very significant bias, but we can see obvious improvements regarding to the speed. Okay, so another thing, so I just covered a little bit of the advanced features actually in GluonNLP regarding the data loader, and then I will talk about the state-of-the-art models we have. So I will cover 2 machine translation models. One is from Google NMT, and Google's NMT is basically the data structure is like this. So it has an encoder-decoder structure. So encoder-decoder structure is very common for sequence-to-sequence tasks, as well as for NLP tasks, because similarly, every NLP task, if you want to model it, you can always model it as a sequence-to-sequence tasks. So encoder is handling the first sequence, and the decoder is handling for the target sequence. So in this decoder, it actually have just a bidirectional scan to as the input, and then use scan, many scan in between the hidden layers, and then use the residual connection to kind of consider the input better. Just try not to lose that much information in the earlier, network stages. And the decoder is very similar structure, but with MLP attention. Okay, so what it has is just attend the encoder's output. So basically, pay attention to some part in the encoder sequence, in the sequence from the encoder, that which part we want to pay more attention, so that we can generate a better targeting sequence. So this network is a little bit actually complex, right? And actually, Google has its own implementation. So in TensorFlow NMT, so the blue score is basically a measure to say if you have a higher blue score, you will have better, kind of quality of motion translation. So we have the 26.1 on the blue score on the one of the on the benchmark dataset, which is IWST 2015. This is one of the benchmark dataset for motion translation, and our implementation it actually can achieve I think 0.1 point higher than TensorFlow original paper's implementation. So that's very, I think that's a good stuff. That's a good thing. Okay. So that's one motion translation model. Another one is a transformer. This is, I think, it's a very hot topic actually in NLP community recently. So motion transformer is basically just regardless of the LSTM, the recurrent neural networks, because it will just because it cannot parallel reading the data, and it needs to go over 10 steps, right? For each sequence, it will go from the first word to the last word until it can make any prediction. So it is very time consuming. So attention is all you need is attention, or transformer is basically leave out all the recurrent neural network, and it just instead it constructs some base encoder, can actually generate similar performance as the RNN or STM. It constructs this kind of network. It has a positional encoding to kind of consider the position in the network, in the sequence of each token, and it has a multi-head attention. It's basically attend to different perspectives in your sequence. Consider whether I want to attend the first portion or the second portion of the sequence, something like that. And multi-head basically contains more dimensions, and then add on some forward stuff to basically kind of generate the encoder's output similar to the previous one, which is leveraging LSTM to generate output. So here they are using this kind of block in the encoder. So this part, the left part is the encoder to generate output, and then the right hand is using an decoder, which is similar. They have similar structures, but also have the similar attention between the encoder's output, which is the second block there. Multi-head attention basically is considering which of the encoder's output is more important that they want to pay attention to. Okay, so this kind of model in Google's original implementation in TensorFlow, they have so the blue score is still the higher the better. They have 2016.55, and we can actually achieve higher blue score. So I think that's also a good thing to know. Okay, so both of these two are state-of-the-art machine translation models. They are now available as a pre-trained machine translation model, or as a structure. You can always directly use it from GluonNLP. Okay. So after talking about the result we have, I think it's important to show actually how can we just write steps we want to begin work on it. For example, if you're interested, you want to really write your own code to do something. I think today I really also want to help you guys to have a basic idea about if you want to really use it, how you can get started. So based on the 3 APIs, the GluonNLP data, GluonNLP models, and as well as the GluonNLP embedding, I think we can already start to write a language model, which is a traditional NLP task. So let me start by introduce a little bit of a language model. So language model is basically, I think it's one sentence. Basically, it's trying to predict the next word based on the previous ones. For example, you have x1, I want to predict x2. You have x2, I want to predict x3. So that's the basic story. So language model is trying to predict the next word. Just keep this in mind. So how to write a language model in GluonNLP is pretty easy, I think. The first step is basically collect the data set. This is actually most of your time will spend on. So normally people in learning community or in NLP community, they pay too much attention on modeling, how to write their own model, but that's not true. So normally in real applications, normally we will spend lots of time on how to handle the data, right? Tuning the data, pre-processing data correctly in order for us to at least train the model. So that's basically most of the time you will spend if you want to leverage GluonNLP. That's the same story. So after that, things will become easier. So if you want to build a model, so it will just require a few lines of code. I will show later. And if you want to have the model, you just define it, you want to start training it, it will also just require a few lines of code. You can just basically start training it. And evaluate is basically just one line of code. You can just evaluate the model whether it's good or not. And inference also same. You can directly get your model and just do the inference. It's just also another one line of code. So let me show you step by step. So first step is basically collect the data set. So the good news is actually GluonNLP has already pre-stored lots of standard benchmark NLP tasks. The data set they use in their NLP tasks. So we have lots of preloaded data set already available. So for example, the VP text 2. So VP text 2 is actually a pre-processed data set from VP. So some people already handled the pre-processing for us, and the format of the VP seems to be clean rather than just a raw VP text data set. So we have that, and GluonNLP just load it in the we actually store it on S3. And we have the dataset. So all you need to worry about is this week test 2 is actually the benchmark dataset for language model. And you can just use one line of code to NLP data wiki test 2 to directly get your training dataset ready for training, for validation, for testing. And then you can use GluonNLP's vocab API to generate the vocabulary needed for your training. So why we need a vocabulary? Because vocabulary will generate some indexes. So later on, right, if you want to make some prediction, you'll basically predict according to the index. Then you will know which word you want to predict. So vocabulary is needed. So vocabulary is only generated based on the training data set, right? There. So vocabulary will generate based on the training data set. Another one of code to generate vocabulary. And then we will get the data ready for training. So we will need to batchify the data set to generate the mini batches ready. So the mini batches will basically, after this, BTP batchify function, just one of code, and then you will have the batchified corpus for the training, validation, and test in the array format, which is a standard tensor format for Gluon. And that's it. That's all you need for collect the data set. For example, if you want to use some data already existing in the GluonNLP, If not, so you only need to change the API in the big text tool. All this is actually based on a corpus dataset, so you can implement your own corpus dataset and just load it in a similar way, and then the batch file and the vocabulary will handle the following things. Then the second step is about build the model. So for building the model, this is a general structure for language model. So what it does is, given a context, welcome, for example, I want to predict the next word. Okay. So what is the next word? So it will first have an embedding layer to kind of construct the features for the welcome. So what is a feature? So rather than, you can use the lookup, which means the one hot vector. So this welcome is just equals to 1. The index is in the vocabulary, and other index is just equals to 0. And this is one hot vocabulary, one hot representation for this welcome. And you can also use other embeddings later on will cover. So this embedding will generate the feature representation for the welcome. And the SQN, several layers of SQN will do a similar thing, like it will just remember the embeddings output and just try to make a prediction, like what is the next word. It will have the stale state, while SQN is good is, in the language model example, is basically it has a memory cell. It can remember what is the welcome if they have already stored it in the history. So they will make a prediction. And for example, it make a prediction. For example, it has it will generate the last SQN layer will generate some output, and I just forgot to mention. So the SQN in between is actually the encoder. Okay, it's actually the encoder in a language model, and the output is actually a decoder. And what is the decoder is basically generate outputs over the vocabulary. So it will have some kind of outputs over the vocabulary, and the softmax will take care of it. So it will after softmax, it will generate distribution over the vocabulary. So you can easily just select the index with the largest vocabulary as your next word. For example, in this case, given welcome, you will have some vocabulary, some probabilities, and you can say 2 has the highest probability. So you're given welcome, and you probably want to make a prediction over the next word. You want to decide which is the next word. Probably the right one is 2. So welcome 2 will be the first iteration of the language model. Okay, and welcome home, welcome back can also be good, but the largest probability is 2. So you probably output 2. So that's what language model does. But in GluonNLP, what you can do is very simple. You want to define this. It looks very complex, but basically in GluonNLP, you can directly leverage the embedding encoder, decoder already in the API. You can directly get it and construct your own language model. And we have this ready. The name of the language model we just constructed in the name scope is standard RNN. So you can see the standard RNN contains the embedding, encoder, decoder, but it's just one of code which is just you can directly map it into the figure here for the model structure for language model. So then later on you get a model. This model is the model you want for make the prediction, and this is your language model. And next, we need to train this model. Just like train over batches of examples in order to have it have better parameters, so in the future it can make a better prediction. So how we can train this model is basically we just initialize the parameters using either uniform or X0, any like parameters, but like uniform X0 is okay. So just initialize the parameter and then just use the parameters and to just initialize the trainer. The trainer is basically optimizer. So we are we are using SGD as the optimizer. So for language model, we suggest use SGD, but for other like tasks, for example, for sequence to sequence, complex cases, for example, machine translation, probably RM is better. But for language model, SGD is okay. So then we need to define the loss. You want to basically, after each main batch, you want to update your parameter according to some loss. Your target is to minimize the loss, so you need to define the loss. So the loss we define is basically the softmax cross entropy. So you can consider the softmax is directly can be aligned to the softmax layer here. So the output of the softmax, we have this API in Gluon that we can directly combine with the loss function, which is cross entropy loss. Okay, then we will have the loss. And then we can just use one of code to train the model. We have this API, then you can just have your model as input, have your train data as input, have your validation test data as input if you want to print out the loss information. And you have the epochs, how many epochs you want to train your model, and you have the learning rate ready for the trainer as well. So then we will just start training. So this process will normally for language model for example, small size language model for the standard RNN, we just saw it will take around 3 or 4 hours. Like if you set an epoch to 40, so it can have some reasonable result, should be ready. Then for evaluation, so if you have the model, then for example you just train like 40 epochs or 10 epochs, you have your parameters ready. So you want to evaluate whether the model is good enough, or you want to see whether is there anything wrong with your model, whether your losses actually goes down rather than goes up, right? Some random numbers. So if you want to look at the loss, you're in the training, so you want to leverage this one of code to evaluate the language model. So the text error is basically the loss on the test data set. You can also print the loss on the validation data set. You can just change the test data to validation data, and the batch size is a batch size you want to use to evaluate the data. So what is the mini batch you want to? Each time you want to input in your model and get the result and then generate loss. Okay. So let's test the loss or validation loss. You can generate it in a similar way. And for inference, so why there is about 2 lines. So basically, I want to show one more thing. So if you don't want to train your model, I don't have time to train my language model. I just want to use my language model. So what you can do is just get model. Directly using this one. This is a model we just saw in the slides. Directly get this model. This is already existing in a model zoom, and you can directly get a model, and you can directly, for example, inference a model on any of your data set. For example, rather than the test data set from the wiki, if you have some data set, for example, your open data set, for example, for bio or for health data, for example. You can directly test the existing model on that and try to, improve it or just use it. Okay, that's a way for you to do inference on it. Excuse me. So finally, I want to talk about, cover a little bit about the embedding, because I think embedding is for general interest and it's very useful. So I think we draw this big picture to see why embedding can be very useful. So embedding can be in any category. So language embedding is one, and graph embedding, for example, image embedding, so on and so forth. But for example, today we want to basically cover the embeddings in NLP domain, which is aligned here. So in language embedding, we will have actually word embedding, sentence embedding, paragraph embedding, even document embedding. Some people are doing that, but just embedding. So for embedding, there are some well-known embeddings: word to act, fast text, and glove. So basically, I just mentioned earlier we have 300 pre-training embedding models ready. So they are all in the category of the word embedding. So they are belongs to fast text and GluonNLP. Besides, we also provide some other stuff that we'll cover later. And for example, the language embedding, to be more specific in our case, is a word embedding, can be directly used to improve many NLP tasks. For example, a language model. So previously I was talking about we can initialize the embedding layer of the language model. So the embedding layer here, we actually only leverage one hot, right? One hot vector. If the index is equals to a welcome, so we will just initialize 1, and otherwise it will be 0. Actually, we can initialize welcome, use some pre-training embedding. Okay, it will actually help the language model to have better performance. So that's one usage we can find here. So language model as one example, and machine translation. Similarly, we can initialize the embedding layer using the pre-training embedding. And for QA, question answering, for example, we have many computation for squad computation, and people are using pre-training embedding to as a starting point to train their system. And the dialogue system, similar. And for example, other embedding, we have graph embedding. We will not have it in GluonNLP, but they are all embeddings. So like graph embedding and image embedding. So probably some combination of the embeddings or even language embedding alone can be serving as a great starting point for many real production in real scenario. For example, recommendation system. So if you want to construct some kind of feature representation for your item or for your own any music or something, you want to generate some kind of representation. So embedding can be the first thing to consider, because you didn't need to worry about the scale of the features meaningless. So word embedding already has been trained on very large scale corpus. It has some good semantic meaning. So can be directly used, for example, for a recommendation system, for information retrieval, IR, and as well for some other advertising stuff. People are using it. And for GluonNLP, we were specifically talking about word embedding. So word embedding, what is word embedding? Basically maps the words or phrases to the from the vocabulary, okay, to real numbers rather than just one hot vector. So we have two. I will basically talk about two word embedding models available in GluonNLP. One is the word-to-vect. So word-to-vect skip-gram model is basically the idea is given the central word WT, and it tries to generate a better representation of other surrounding words. So basically, the simple idea is basically the word appear many times similarly in one sentence. Like many words appear at the same time in one sentence. The more it happens, the more similar the presentation of the word should be. Okay, so this is a basic intuition, and if you want to train your model, this is just the lines of code you want to leverage, because the original model is available, and if you are doing something, you just need to change this part. And the faster text is basically handling the unknown word. I basically want to let you guys know, so if some word you just didn't saw in your vocabulary, and it happens in your online application, for example, recommendation or something. So if you want to still generate a meaningful representation for the word, basically something you can do is basically leverage fast text, because it is generating the presentation for each character. So you can, for any word, it's combined with a character, right? So we can kind of leverage averaging, for example, the representation for each character to generate the final representation for the word. So there will be no unknown token, there will be no embedding for example, available in the word-to-vect. So, but for fast text, any word will have a meaningful representation. So, so I really want to show something can run and you can see the result. And for the embedding, so normally there are two evaluation metrics. One is similarity. So the idea is very simple. If the two words have similar embedding, which is in the form of vector, they should be similar. Okay. So if you think these words are similar, and we can just use one of the word embedding models to just convert the word into embeddings, and we expect the presentation to be similar, right? The web vector to be similar, we can use cosine similarity to measure that. The second one is analogy. So given, for example, two words, and you want to kind of, for example, I will later on we'll show this case. Okay, we will just show this example. So here, this is actually the homepage of the GluonNLP, and actually in the we have a running example. So here, so a quick example is we are just import MXNet and import GluonNLP, right? And we are just load the pre-trained embedding directly. We are using GluonNLP, for example, here. We are using one particular GluonNLP settings, which is each of the word will have 15 dimensions. So for example, any word will have 15 dimension vector to present the word. And we are using the GluonNLP word, we are just generating. We will just load it to convert the word into vectors. Okay, we are convert baby and infant into vectors. So basically, we expect the baby and the infant should be similar, right? And then we are defining. Let me first run this first. So this is available on the website. Anyone can click this, and it will start first. Downloading the MXNet and the GluonNLP and install some relevant stuffs. Okay, so it's running. So let me continue. So the cosine similarity is basically if these two vectors are similar, so the cosine similarity should be expected to be higher, right? So finally we will print what is the similarity between the baby and the infant. And we expect the similarity to be high because baby and infant are conceptually similar. Okay. Let's wait for running because it's downloading the GluonNLP model as well, so it will take some time. But finally, we got the result here. So similarity between baby and the infant is something 0.7. So it looks reasonable. So that's one example. Another example that we just show the example of the. Or you guys can give me some like. I'm not sure whether we can quickly do it. For example, we want to know the similarity between what?
MXNet, white torch.
Probably it's not in the vocabulary. Yeah, something reasonable in the vocabulary you can think about. Cat with what?
Dog.
Cat with
Lion.
dog?
Lion.
Lion. Okay. Reasonable. That's it. Okay, let's just run it one more time. Oh, every time, because it's in the front end, so every time it will try to load the downloading MXNet and GluonNLP, it will take some time. We will fix it. Okay. Anyway, at the same time, I think we can go to another example. So analogy. Analogy is basically let me go to place. Okay. So actually, this is also on the GluonNLP. So actually, in examples, you can see we have the how to use word embedding, how to use word embedding training. If you want to train old model, how to use language modeling. Some of the stuff I just covered is there. How to construct your own semantic analysis to to decide whether the review is positive or negative in terms of the segment. So here, this one, actually, I just want to show you this. So the application of the word embedding, one is the cosine stuff. So another one is the similarity and word analogy is here. So definition of the word analogy is like this. So given man, woman, and a given son, we expect another item of this should be daughter, because man is, man compared to woman is like son compared to daughter, conceptually, semantically. Okay? So what we can do is we can get the top K analogy of the man, woman, and a given son, right? And we can see from the, it should be still generated from the glove, and we can see the first one is daughter. And similarly, we can see Beijing to China is compared to Tokyo to Japan. So it's because Beijing is the capital of China, Tokyo is the capital of Japan, right? So they are all conceptually like similar compared to each other. And then this case is also interesting, like bad to worst is similar to big to biggest. So you can learn the stance of the word or the tense of the word. Tense of the word is here. So do to deep is similar to go to wet. So that's conceptually similar. So what embedding is actually handling this is try to learn the similarity between words, try to map the words similar to the same vector space. So that means the vector for similar words should be similar. So let's see what we got. I still baby and then, okay, because we changed the cat and the line here. So the similarity between cat and the line is all one side. Okay, that's good. Okay. Yeah, that's basically some interesting stuff you can do with embedding. Okay, so I guess I need to conclude my talk. Yeah, it's about time. Okay, nice. So I want to talk about what is the current GluonNLP status. So we have the state-of-the-art models for embedding, a language model, machine translation, and semantic analysis. And more is coming. Is more means QA, question answering, coming soon, and abstraction is coming soon. Summarization is coming soon. Okay, so I'm talking about this is because if you guys are interested, you can definitely work with us to contribute to this. So more and more will be coming. So another thing we want to mention is that so you just saw the examples for the embeddings. For embeddings, for example, here we have the embedding example. You can. This is runnable. I just don't have time to run it. This is runnable. It should generate similar result as shown here. And the language model, we have. If you don't want to spend time to just search for what is language model, just go to example in GluonNLP, and you probably will find everything you want to know. How to train your own language model, how to train your own language model on your own dataset, how to directly use the model in the model. So, and as well as the semantic analysis, we also have an example, right? How to use the language model as a starting point to train your semantic analysis, and it generates some reasonable results. So, for example, if you want to decide what's the sentiment for this movie is amazing, so it generates 0.7. So the larger means more positive. So it means okay, this is a positive review regarding to the movie. So we have some examples. I guess they are relatively easy for you to review, similar to what I just talked in the language model. So another stuff is we have some scripts. scripts as here. Scripts are basically reproducing state-of-the-art models, so it's longer. So you can see we have the word embedding scripts, we have the language model scripts, and this is how to catch up with the state-of-the-art results. And this is semantic analysis, additional machine translation. So GluonNLP I just covered, as well as transformer of the transformer model. You can use this line to get to the state-of-the-art transformer, or this line to reproduce the state-of-the-art GluonNLP seamlessly in language model. So that's one I want to mention a little bit. And regarding to the more features, so I just cover the marketing. I just cover the marketing as well as load the many public dataset. One we load is just make the text tool for the language model, and the text data processing. I just cover the marketing, and the modeling we are not using any of them. Embedding, we just show an example to use pre-training embedding to kind of mirror similarity between cat and lion, for example. So that's basically what we just covered in this talk, but many more are still available if you just go to check our website. And in summary, we just provide, in the GluonNLP, we provide some high-level APIs for NLP tasks, for example, GluonNLP.data.model.embedding. And we also provide some low-level APIs, for example, GluonNLP data batch file, so you can easily batch file your data, just enable it for training. And the model standard, we just directly can load the model structure directly from the model zone and use it for training. One thing we want to focus is we are designing this GluonNLP for practitioners, and for both researchers and engineers. So I think we are welcome to work with you guys if you are interested, and we can make contributions together. So thanks, and I think that's basically what I want to cover in this talk. Thank you, guys. This is the website you can check out.
I have a question. So there's the Sakai toolkit from the Berlin team. I was wondering if you guys are planning to just port all those models into MXNet, or
So all of these models are currently in GluonNLP model zone. So it's not in SageMaker. The reason that SageMaker is more on, you can easily probably just optimize the parameters. Like you can cite some parameters just in the configure JSON, something like that. You can easily train. This is more flexible in terms of the writing code, so you can easily use the API. So it's more like a framework than a service. Yeah, but the models are all in the GluonNLP model for now.
And I guess I have a second question for you.
Sure.
So you mentioned the transformer model. Are you guys planning to have any other non-auto-regressive models for Gluon? For example, there's a Facebook model that is also non-auto-regressive. I don't know if you guys are.
Yeah, that's a good question. So the convolution sequence-to-sequence model, yes, we have the convolution encoder ready. We didn't put the model. If you are interested, you really can. We really can work together on that. So because you can see from the API document, you can see, if you click on this, you can see lots of some APIs here. And for the convolution, we have the convolution encoder. So it's actually replacing the recurrent input using, instead of you can directly using the convolution encoder, and combined with highway will be basically the Facebook machine translation model. If you're interested, you can ping me on this. Yes.
Okay, thank you very much.
Okay.